the process of actually making myelin is called myelination. Another slightly large word, but basically very simple, meaning just making myelin. How does this happen? So we have a situation in early life, just before birth, where there are nerve fibres growing through the brain, and there are oligodendrocyte precursors, as Yuti mentioned earlier. These are basically baby oligodendrocytes studied throughout the brain as well. These baby oligodendrocytes will mature, they'll grow up, and they become cells, as Yuti showed you with the diagram where the procession of the oligodendrocyte from a precursor right the way through to a myelinating cell. This will happen as they develop, and by the time that myelination takes place, these cells are fully capable of making myelin. They push out a process from the cell surface which contacts a nerve fibre, as you can see in A at the top here. This flattens out into a sheet-like structure and begins to wrap around the nerve, as you can see in B. And it will then wrap under itself and continue wrapping around and make very tight wraps around this nerve. Now, as this happens, there are proteins in this myelin which actually act almost like Velcro and really stick the myelin down very tightly against the axon. The axon also reacts. This is an interaction. It's not a one-way process. The nerve and the myelin interact with each other, and the nerve fibre will actually potentially grow in diameter, and this again makes the nerve signals travel faster. Demyelination. Why is this important in multiple sclerosis? Demyelination is a fundamental process in multiple sclerosis, and it means the destruction of the myelin sheath, as I'm sure you could probably guess. Myelin is a very vulnerable substance. It's a fatty substance, and because of the way it's made up, it's very vulnerable to certain attacks that happen in multiple sclerosis. You may have heard of these words cytokines, free radicals. These are basically chemicals which get into the brain and are released in the brain during multiple sclerosis and do damage to the myelin. They can directly damage myelin sheaths, as we can see here. So this is a very basic representation of what happens in multiple sclerosis, and you've heard all about different aspects of this throughout the day. Basically, from the blood, we have invading T and B cells which cross the blood-brain barrier across into the brain tissue. And once in there, they can produce these inflammatory mediators, as we call them, including cytokines, including free radicals, which then impact on nerve cells, and as we can see here, strip away the myelin, damage the myelin, eventually strip it away, and eventually start damaging the axon itself. And the myelin is actually eaten up by macrophages in this lesion area. So we know about that. Obviously, myelin plays a central role in multiple sclerosis. The consequences of demyelination are numerous, but all of the positive things that I said about myelination earlier basically are reversed. Nerve signals slow down, they are not able to travel so quickly, they're not able to travel over very great distances, certainly through a lesion, and this leads to the symptoms. There are also crossing over of signals between different nerves, which leads to confused signals. So all of these things lead to symptoms, similar to the way that Sarah mentioned a minute ago. Also, this layer is protective. The layer of myelin around the nerve actually protects the nerve. It nourishes it, but it also protects it physically. So removal of this myelin layer actually removes a layer of protection for the neuron. So it's more vulnerable to damage by mediators. Some lesions repair themselves, and some do not.